Right now, you are sitting on a rock, hurling through the silent darkness of space at over 67 miles per hour. That rock orbits a nuclear furnace a million times its size, and that furnace is just one of 400 billion stars spinning through a galaxy so vast that light itself, the fastest thing in existence, needs 1,000 years to cross it. But here is what will shatter your perception of reality. Our entire galaxy, with all its billions of worlds, is nothing more than a single grain of sand in an ocean containing 2 trillion other grains. This is the story of scale, a journey from our familiar home to the very edge of what we can know. Prepare yourselves, because we are about to discover how small our world, our galaxy, and our entire universe truly are. In a clear night, the sky appears as a familiar ceiling, a dome of glittering lights that seem just beyond our reach. To the ancient Greeks, they were whole spoke in a celestial sphere. To our eyes, the brighter star in the sky, Sirius, seems close enough to touch with a sufficiently tall ladder. The confirmed reality shatters this illusion completely. Sirius lies 8.6 light-years away from Earth. A light-year is the language of the cosmos, the distance light travels in a single year, nearly 6 trillion miles. To comprehend this, imagine you could drive a car at highway speeds towards this nearest bright star. The journey will require more than 9 million years. You will need to have started your trip long before the first human ancestor walked the Earth. And in cosmic terms, Sirius is our next door neighbor. This is the first profound shock to human intuition, the emptiness. If our sun were a basketball, Earth will be a grain of sand orbiting from 26 feet away. The nearest star will be another basketball not in the next room or the next street, but in another city. Everything in between is an almost perfect vacuum, a void of an unimaginable scale. This emptiness defines our cosmic neighborhood. It's the reason why, despite the billions of stars in our galaxies, the cosmos is a real and profound loneliness. Now, let's take the next step. Every single point of light you can see in the night sky belongs to our home, the Milky Way galaxy. Picture yourself standing in the middle of New York City at midnight. Now imagine that cityscape stretching not just across America, but across the entire Earth. Then multiply that distance by 6 billion. You have just visualized the width of our galaxy. It is a city of stars 1,000 light years from edge to edge. The light-living stars on the far side of our galaxy tonight began its journey when early humans first learned to make fire. We are looking at a patchwork of different time periods, a photograph of a past. We live inside this cosmic city, embedded within its structures like a single cell in a massive organism. Our solar system resides in a quiet suburb, the Orion Arm, roughly 27,000 light years from the chaotic galactic center. Our entire solar system orbits this center just once every 230 million years. The last time we were on this position, dinosaurs were just beginning to walk the Earth. This galaxy is a dynamic ecosystem. In vast stellar nurseries like the Orion Nebula, gravity sculpts clouds of gas into burning spheres. New stars are born. Elsewhere, ancient red giants expire in spectacular explosions, seeding space with the heavy elements, the carbon, the oxygen, the iron, that are necessary for life itself. Every atom in your body, heavier than hydrogen, was forged in the heart of a star that lived and died long ago. We are quite literally made of stardust. For millennia, we believed our galaxy was the entire universe, but in the 1920s, a startling discovery was made. Faint, fuzzy patches in the sky were not clouds within our own galaxy, but entire galaxies in their own right. Look toward the constellation of Andromeda. That faint smudge of light is another island of stars. Our nearest major neighbor, the Andromeda galaxy, it is more than twice the size of the Milky Way, containing over 1 trillion stars. The light you see from it tonight began its journey 2,005 billion years ago, when our ancestors were just learning to use stone tools. But Andromeda is more than just a distant neighbor. It is on a collision course with us, racing toward our galaxy at 250,000 miles per hour. In about 4.5 billion years, these two galactic titans will merge in a gravitational dance lasting hundreds of millions of years. Stars will be flying into new orbits. The night sky will be set ablaze with star formation, and our two-spiral galaxy will be reshaped into a single, giant elliptical galaxy which astronomers have already nicknamed Milkomeda. Together, our Milky Way, Andromeda, and over 50 small dwarf galaxies like the Magellanic Clouds are all bound together by gravity. This is our extended family, our galactic neighborhood, the local group. And even this colossal family is just the beginning. The local group, spanning 10 million light years, may seem immense, but it is merely a suburb of a much larger cosmic metropolis. Our intergalactic neighborhood is being pulled by gravity toward the heart of the Virgo cluster, a collection of over 1,300 galaxies, 54 million light years away. When astronomers studied these clusters, they found a profound mystery. The galaxies within were moving so fast that the gravity from the stars we can see shouldn't be nearly enough to hold them together. They should have flown apart billions of years. The solution was a radical idea. The clusters are held together by a substance we cannot see, an invisible gravitational scaffolding known as dark matter. This mysterious substance, which makes about 27% of the universe, reveals itself only through its gravitational pull, bending the very fabric of space-time and the light that travels through it. We can map its presence, but we have no idea what it is. It is the invincible skeleton upon which the intercosmos is built. These clusters of galaxies are themselves organized into even grander structures. Our Virgo cluster is just one arm of an immense supercluster of galaxies, a collection of clusters that we call Laniakea, a Hawaiian name meaning immeasurable heaven. It spans over 500 million light years and contains the mass of 100 quadrillion suns. Our Milky Way is but a single speck of dust within this celestial continent. But what happens when we zoom out even further, past the scale of superclusters? A stunning pattern emerges. The universe is not a random scattering of galaxies. It is a vast, three-dimensional network, a cosmic web. This web is the largest scale structure in the universe. It consists of 4 distinct components. Dense nodes, the intersections of the web, are where galaxies cluster form. Stretching between them are colossal filaments, cosmic highways channeling gas and galaxies across billions of light years. Where these filaments intersect, they form vast sheets of galaxies known as galactic walls. And between all of these structures lie the cosmic voids, unfathomably large regions of near-perfect emptiness. These voids are cosmic deserts. The void's void, for example, is a sphere of space 330 million light years across that contains almost nothing. If our galaxy were at its center, we would not have known other galaxies existed until the 1960s. The night sky will be an almost unbroken black. In contrast, the filaments can form structures of mind-bending scale. The Hercules Corona Borealis Great Wall is a sheet of galaxies so large it measures 10 million light years across. Light takes longer than the age of our own solar system just to travel from one end to the other. Its very existence challenges our fundamental assumption that the universe should look roughly the same everywhere on the larger scales. So, within this cosmic web, how many galaxies are there? In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky that appeared completely empty, a region no larger than a grain of sand held at arm's length. They left the shutter open for 10 days, collecting every single photon that arrived. The result was a revelation that changed human perspective forever. That tiny empty patch of sky was filled with over 3,000 galaxies, each one a city of billions of stars. Based on this and other deep-field observations, Astronomers have calculated the total galaxy population within our observable universe. The number is staggering: 2 trillion galaxies, 2 million million. Consider this: there are more stars in our observable universe than there are grains of sand on every single beach on planet Earth. For every tiny grain of sand you can hold in your hand, the cosmos holds thousands of suns, many with their own planets, their own possibilities for life. And all of this, every star, every galaxy, every cosmic wall we have or ever observed, exists inside the bubble. The bubble of our observable universe, a sphere 93 billion light years in the diameter. This isn't a physical edge, it's a horizon of light, the boundary of what we can see, because light from any farther away hasn't had enough time to reach us since the beginning of time. For most of the 20th century, the biggest question in cosmology was the fate of the universe. Would gravity eventually halt its expansion, pulling everything back together in a big crunch? In 1998, two teams of astronomers studying distant supernova found the shocking answer. The universe's expansion wasn't slowing down, it was accelerating. Something invisible is tearing the universe apart, a mysterious repulsive force that physicists have named dark energy. It makes up 68% of everything in the cosmos. It is the dominant force in the universe, a sort of anti-gravity woven into the fabric of space itself. This discovery seals our ultimate fate. On local scales, gravity still wins. Our local group will merge, but on the grand set scales, dark energy is undefeated. It is pushing distant galaxies away from us at ever-increasing speeds. Galaxies at the edge of our observable universe are already receding from us faster than the speed of light, not because they are moving through space that fast, but because space itself is being stretched between us. This leads to a chilling conclusion: a future of cosmic isolation. In 2 trillion years, every galaxy beyond our local group will have been pushed beyond our cosmic horizon. Their light red-shifted into nothingness. Future astronomers in the Milky Way galaxy will gaze out into night sky that is utterly black and empty. They may have no way of ever knowing that a universe of 2 trillion other galaxies ever existed. The evidence of the Big Bang and our cosmic origins will be erased. To understand our origin, we must travel back to the edge of our observational limit. This is the cosmic microwave background, the oldest light in the universe. It is the afterglow of the Big Bang, a wall of light emitted when the universe was just 380,000 years old. Before this moment, the universe was a hot, dense, opaque fog of plasma. Light couldn't travel freely, but as the universe expanded and cooled, atoms formed, and space suddenly became transparent. The light from that moment has been traveling across the cosmos ever since, and we see it today as this faint microwave glow in every direction we look. It is a baby picture of the universe. The tiny temperature fluctuations you see are the seeds stretched by cosmic expansion that grew into the entire cosmic web we see today. But what happened before that, our theory suggests that in the very first fraction of a second, the universe underwent a period of unimaginable expansion called cosmic inflation. A region smaller than a proton inflated to a size larger than our entire observable universe, all in less than a trillionth of a second. This theory explains why the universe is so big and flat. And it leads to the most mind-bending idea of all. If inflation happened once, why would it stop? The theory of eternal inflation suggests that our universe is just one bubble that inflated out of infinitely larger. Eternally inflating a metaverse, new bubble universe are constantly being born, each one potentially with different laws of physics, different fundamental constants. This is the scientific basis for the multiverse, an infinite ocean of universes of which ours is just one isolated bubble. In such a reality, anything that can happen will happen. There will be infinite universe where dinosaurs never went extinct, infinite universes where Earth never formed, and if the multiverse is truly infinite, There will be infinite copies of you, living out of every possible variation of your life. This is the frontier of theoretical physics, a reality so vast and strange we may never be able to prove it exists. The 93 billion light-year sphere we call our universe with its 2 trillion galaxies may itself be an infinitesimal speck in a truly infinite creation. So where does this live? Adrift in a cosmic ocean on a single grain of sun. It's a perspective that can feel terrifying, that can make human existence seem cosmically insignificant. But there is another way to see it. The observable universe is a peer with us at its center. This isn't because we are special, but because we are observer. An alien astronomer in a distant galaxy sees themselves at the center of their own observable universe. With our galaxy near the edge of their vision, it is a universe defined by perspective. And while our view is vast, our sphere of influence is tiny and shrinking. The region of space we could ever hope to communicate with is being constantly eroded by dark energy. We are profoundly isolated, a lonely island of intelligence in a silent sea. But this is where the story turns. The vastness of space is not just outside of us, it is also within us. The iron in your blood, the calcium in your bones, the oxygen you breathe, every building block of your body was forged in the heart of an exploding star billions of years ago. You are a child of the cosmos. The same physical laws that sculpted galaxies and ignited the stars also gave rise to the complex chemistry that led to life, and eventually to consciousness. On this small planet, a tiny part of the universe has woken up. We are the cosmos made aware. We are the matter that can contemplate itself. Our brains, evolved for survival on the African plains, have somehow developed the capacity to map the large-scale structure of the universe, to detect the afterglow of the Big Bang, and to write poetry about the stars. This is the paradox and the miracle of our existence. The journey to understand the scale of reality is a humbling one. We live on one planet, orbiting one star in one galaxy among 2 trillion, in an observable universe that may be a tiny part of an infinite multiverse. We are infinitesimally small, and yet we are also infinitely precious, because we can see it, we can understand it. We are the universe's way of knowing itself. So the next time you look up at the night sky, don't just feel small, feel connected. Feel the legacy of exploded stars within you. Feel the wonder of being a conscious part of this vast, mysterious, and magnificent cosmos. The universe is not only stranger than we imagine, it is a stranger that we can imagine. And for a brief, wondrous moment, we are here to witness it.